The question haunts us. Is there a better way? What if we looked up? What if we took our most dangerous creation and gave it a cosmic burial, and shot it into space? Beneath our feet, under layers of concrete and steel, a silent poison waits. It is the ghost of our own creation, the byproduct of a power that lit our cities and fueled our progress. High-level nuclear waste, a legacy of radioactive material that will remain deadly for over 100,000 years. Longer than human civilization has existed. We bury it, hoping the Earth will be its permanent tomb. We guard it, hoping our descendants will remember the danger. But the Earth is a living, breathing planet. Tectonic plates shift, water tables rise, and civilizations fall. The question haunts us, a whisper in the back of our scientific consciousness. Is there a better way? A permanent solution? What if we looked up? What if we took our most dangerous creation and gave it a cosmic burial? What if we gathered every last gram of spent nuclear fuel, sealed it in an indestructible vessel, and shot it into space? The idea is seductive in its simplicity. An ultimate act of cosmic housekeeping. The theoretical plan to remove our nuclear burden from the planet entirely. The process would be a marvel of engineering. First, the waste would be vitrified, fused into a solid, glass-like state, making it incredibly stable. This radioactive glass would then be sealed within multi-layered casks, celestial caskets designed to withstand unimaginable forces. They would be radiation-proof, corrosion-proof, and capable of surviving a fall from orbit. But where would we send it? The destination is everything. Low Earth orbit is out of the question. A collision with space debris could create a glittering cloud of death, a radioactive Kessler syndrome that would make space travel impossible and rain down poison for centuries. The Moon? A tempting junkyard, but it's our closest celestial neighbor. Future colonization, mining operations, we would simply be moving our problem from our backyard to our front porch. What about further out? Venus? Mars? Planets we may one day wish to understand, to visit, to perhaps even call home. To contaminate them with our atomic sins before we even set foot there seems like the ultimate act of cosmic vandalism. And so, we arrive at the one, seemingly perfect destination. The ultimate incinerator. The Sun. A star so vast and violent, its core is a continuous nuclear furnace. What is our waste compared to that? A single drop of poison in a raging ocean of fire. The plan would be to launch the cask not directly at the Sun, which would require an enormous amount of energy to cancel out Earth's orbital velocity, but into a decaying orbit. Using a planet like Jupiter for a gravitational assist, we could slingshot our package on a trajectory that would, over time, cause it to fall into our star. It would be vaporized, its atoms torn apart and scattered, rendered utterly harmless, absorbed into the stellar fusion that gives us life. A clean, final, poetic end. The problem would be gone. Forever. But there is a catch. A terrifying, planet-altering catch. To get our cosmic casket to the Sun, it must first survive the most dangerous part of its journey. The first 8 minutes. The fiery ascent from the surface of the Earth through our atmosphere. We have become accustomed to the spectacle of a rocket launch. We cheer for its success, but we forget its inherent violence. It is a controlled explosion, a delicate dance on the razor's edge of catastrophe. We have launched thousands of rockets, and our success rate is impressive. But it is not 100%. Not even close. Rockets explode on the launch pad. They disintegrate mid-flight. Payload fairings fail to separate. Guidance systems glitch. For sending up satellites or astronauts, this risk, while tragic, is contained. But when the payload is a concentrated collection of the most lethal substances ever created, the stakes change entirely. Imagine it. The countdown reaches 0. The engines ignite with a ground-shaking roar. The colossal vehicle begins its climb, carrying its radioactive ghost towards the heavens. But then a flicker. An anomaly. A structural failure, an engine malfunction. In a fraction of a second, hope turns to horror. An explosion in the upper atmosphere, perhaps 40 or 50 kilometers high. The indestructible cask, designed to survive a fall from orbit, may well survive the blast itself. but it cannot protect its contents from the sheer pulverizing force of a massive chemical explosion. The nuclear waste, the vitrified glass, would be atomized, reduced to a fine, invisible dust. A radiological cloud containing plutonium-239, cesium-137, and strontium-90, now caught in the high-altitude jet streams. This radioactive ghost would be unstoppable. It would ride the winds, crossing continents and oceans in a matter of days. Undetectable to the naked eye, but deadly to any living thing it touches. It would fall with the rain, settle on our crops, contaminate our rivers, our lakes, our oceans. It wouldn't be a localized disaster like Chernobyl or Fukushima. It would be a global event, an atmospheric poison, distributed unevenly but inescapably across the entire planet. The cleanup would be impossible. How do you clean the air itself? The consequences would last for millennia, etching a legacy of cancer and genetic damage into the very fabric of life on Earth. The cost of a single failure would be the contamination of our entire world. And this is the paradox. This is the suspense of the cosmic gamble. To rid our world of a generational poison, we must risk poisoning it all at once. The cost of success is astronomical, running into the trillions of dollars to launch the sheer volume of waste we've produced. But the cost of failure is everything. It is a game of Russian roulette where the gun is pointed at the head of every living thing on the planet. And so, the waste remains beneath our feet, a silent, sleeping monster. We look to the stars not as a cosmic dumping ground, but with a renewed sense of responsibility. The solution to our earthly problems, it seems, must be found here, on Earth. Because in the vast, unforgiving emptiness of space, there is no room for error.